Hi guys, so today we're going to find a derivative still using the power rule, but we're also going to show just when a constant times the power, we've already done this with the power rule, that we can move the constant outside to just derive the function with respect to x. So I'll show you that for number 2 and 3, but just kind of a reminder first for the derivative. um, f of x equals 4x to the third power. To use the power rule, we're going to multiply the exponent and the coefficient, and that will give us 12. And remember to always take 1 away from the power. And just, it's a simpler way. You still have to know the difference quotient. I just want to put that out there, but you can find the derivative this way as well, as long as your instructor says you can. Now, I just wanted to follow up with this. So you're going to find the slope of the derivative at x equals -1. So f prime of -1 means I'm going to take my function, and I wanted to address this because when you're using the difference quotient, remember, you're not going to plug in the value of x or t or whatever they gave you until you have fully determined the derivative using the difference quotient. Even if it's in terms of x and h, I get it. You have to apply the variables and it gets a little confusing, but make sure that you don't actually substitute in the value they give you until you have found the derivative completely. So, now that that side note is done, I'm going to take 12 and I'm going to replace the x with -1. Again, make sure that you replace anything substituted in parentheses because this shows that only -1 is squared. Remember, x only belongs, or the exponent only belongs to x because it's not in parentheses, so it doesn't belong to the 12. So because of that, using PEMDAS, we're going to do exponents first, -1 to the second power. Mind you, we would do parentheses first, but there's nothing in there. So next is exponents, -1 to the second power. Make sure that you have the parentheses, because I know a lot of you already know this, but -1 squared would give you +1. However, plug it into the calculator without parentheses, and it will not take the -1 and square it. It will only take the number or letter, in most cases, closest to it, meaning it will only square the 1 and bring the negative down. So make sure that you are always going to put it in parentheses, even in the calculator. And then 12 times 1 gives me 12. So same thing for part C. I'm going to take the derivative and replace x, sorry, with +1 this time. So 12 times 1 squared. So this one is a little more straightforward because I'm only squaring a +1, which would give me 1. And then 1 times 12 would also give me 12. But I just wanted to note that. Make sure that you are substituting in parentheses for that reason. Now, for the derivative of a constant times the power. We're already kind of doing that with the power rule, but I just wanted to make it a little bit more specific here. If you wanted to take the derivative of 2 sine of x, technically you could move this constant that doesn't have anything to do with x and put it on the outside to derive only sine of x. It's still together. I'm still going to bring it all down. So g prime of x equals 2. So what is the derivative of sine of x? Well, a lot of you did use the difference quotient to determine the derivative of the trig functions already, but in case you don't remember, there is a little sheet I've made up of all the derivatives of trig functions, inverse trig functions, logs, exponentials, just in case. Screenshot away. So just looking at the second one, the derivative of sine is cosine, and you can prove that using the difference quotient. So I'm going to go back to the other slide now, so I hope you all got this note. So the derivative of sine is cosine of x, and that's it. So when you see the 2, you can always move it to the outside and just derive the function with respect to x. So we're only deriving with respect to x, so I'm just throwing that out there. And now for the other one, h of x equals cosine of x over 2. Remember that technically in front of any variable, in front of any trig function, in front of anything that you don't see a coefficient will just be 1. So if I really wanted to rewrite this so that I could just move the constant, This would be 1/2 times cosine of x. If I multiply straight across, which the fraction form of cosine is cosine over 1, it would still bring me right back up to cosine x over 2. So you can always, apply the algebra and it should bring you back to the previous line just to make sure you're correct. Now, with that, I can start to find the derivative by moving the constant out and only taking the derivative with respect to x of cosine of x. And if you guys took the screenshot, the derivative of cosine of x is negative sine of x. So I have 1/2 times negative sine of x. So that would give me, I'm going to go up here, negative 1/2 sine of x. All I did was move the negative to the front of the coefficient. Or you could write it as negative sine x over 2, again, because we just multiply the fraction straight across. Either one of these will be fine, and I'm only saying that because you do have multiple choice in your assignments, and it could be either one of these. All right, guys, I hope this helps.